In this example, we are required to find the equivalent capacitance of the circuit of several capacitors shown in figure between terminals A and B. And we are also given that the capacitance of each capacitor is 1 microfarad here. Now, in the given circuit, we first need to reduce the circuit into its simplified form. And here we can see that these two capacitors are connected in series and these two are also connected in series. And we know when two identical capacitors are in series, their equivalent capacitance can be written as C by 2. So if we just reduce the circuit into a simplified form, here we can see from this terminal A, a capacitor C is connected and another capacitor, these two we can combine as an equivalent capacitance C by 2, and this is the capacitor C which is connected here, and this is the terminal B, and between terminals A and B in this branch we can also connect another capacitance which is C by 2, that is the equivalent capacitance of these two capacitors in series. Now in this system we can see that the C and C by 2 are connected in parallel because both the terminals of both the capacitors are connected to each other. And in parallel combination we know that capacitances are added up. So this will become an equivalent capacitance 3C by 2, which in turn can be taken in series combination with C. So if we further simplify and reduce the circuit, you can see across this terminal A there is a capacitor C. In series combination with this C, there is another capacitor 3C by 2. And here, this is the terminal B. And between terminal A and B, we can connect this capacitance C by 2. Now, in this final circuit, you can see that this capacitor C and 3C by 2 are connected in series, which in turn in parallel with this capacitor C by 2. So it can be further reduced by taking C and 3C by 2 in series, and this C equivalent can be written as C1. This combination I am writing as a capacitor C1, which can be written as series combination of C and 3C by 2, which can be written as C multiplied by 3C by 2 upon C plus 3C by 2. Because when two capacitors C1 and C2 are in series, their equivalent capacitance is C1 C2 upon C1 plus C2. So here on simplifying we can see the C gets cancelled out, it is 3 by 2 upon 5 by 2. So it will be 3 by 5C. Now if we further reduce the circuit, it can be drawn like this. Across terminals A and B, there are only two capacitors we are having. One is 3C by 5. And other is the capacitor C by 2. They are connected in parallel combination across terminals A and B. So final capacitance across terminal A and B is the parallel combination of 3C by 5 and C by 2, which will be finally added up. This will be 3C by 5 plus C by 2. And on adding these two, we are getting the final capacitance as 11C by 10. And as we are given that each capacitor is of capacitance 1 microfarad, if we substitute C as 1, this will be 11 by 10, that is 1.1 microfarad. That will be the answer to this question. This is the final capacitance across terminals A and B in the circuit shown in figure.